driver profile, weather conditions, traffic density, and delivery distance. Based on this predicted risk, we dynamically calculate the insurance premium using a simple scaling formula. This ensures that drivers working on higher risk environments pay a fair data-driven premium. Next is the parametric trigger engine. Storms are detected in a driver's location, the system automatically triggers a claim state. This enables instant financial support without delays or paperwork. When is triggered, it is passed to the claims and fraud investigation agent. Here, we use an isolation forest model for anomaly detection. The system checks whether the claim data deviates significantly from normal patterns. For example, if most drivers experience a 40-minute delay, but one claim shows as an unusually high delay for a short distance, it gets flagged as suspicious and rejected. If the claim passes this statistical check, it moves to the final layer, the multimodal evidence agent. This uses a vision-based large language model to analyze uploaded images. The system verifies whether the disruption is due to environmental factors like floods or storms. It strictly rejects cases like vehicle damage or personal accident, since those are outside the policy scope, putting it finally visual verification before initiating payouts. From a technical standpoint, this system is built using a Flask backend, which models serve efficiently and pre-processing steps like encoding and class balance